Welcome back, and today we're going to discuss the following theorem that you see in front of you. Let me get my little pen out here and let's try to take this theorem apart. Kind of an existence theorem, okay? The mean value theorem, okay? The mean value theorem for derivatives. Given, so what are the givens? So the given that f of x, sometimes givens are called hypotheses, but I think it's a condition. I'd call it a condition. Given f of x satisfies two things. It has to be continuous on the closed interval, continuous on, notice the closed interval, a, b, and second condition, given that f prime of x exists on the open interval, maybe I should make this 1, 2 conditions, not to confuse A and B. Then there is a point, there's a point x equal to c. C, what does this say? C is somewhere between A and B such that the derivative at C is equal to f of B minus f of A over B minus A. Okay, what the heck does that mean? We need to get some kind of graph here, and maybe I will extend the page in this case. Here we're going to draw a picture. Let's get a picture. And again, get yourself a good picture, and we'll do what? We're going to go, let's go from A to B, and maybe we'll go like that, okay? Here's my function. Now, what this says is, this right here, what does this look like? Well, first of all, does this satisfy the conditions? Yes, this function is continuous on the closed interval, and you notice there's no sharp edges, so the derivative exists. So, check mark on 1 and 2, those exist. Now, let's get another pen out here. Notice what this is. This is just the average slope of the function, right? This is what? This is the slope of the secant line. What is that? What's the change in y? Well, that's f of b minus f of a. What's the change in x? b minus a. So this is equal to slope of secant line. Okay? And what this says is that if you satisfy the conditions, there has to be a point C. There exists a point x equal to c where the derivative is equal to that. Well, let's change slopes. Let's change this again. Do you see a point here? I'm just graphically, let's see. Oh, that looks like, notice if they have this, f prime of c is what? This is the slope of the tangent line. That is the slope of the tangent line. So this could be c, okay? So notice f prime at c, notice these are parallel lines. These are parallel lines with the same slope. So there has to be, the mean value theorem guarantees that there's at least one point C in this interval such that the instantaneous slope equals the average slope. So this might be this is the instantaneous slope in instantaneous slope is equal to what? Well, that's the average slope. In this case, there's 2 points, aren't there? There's actually 2 points. The theorem doesn't say if there's more than one. It just knows it. You know, there could be more than one. But there has to be at least one. Remember, if I start here and if I go up, I have to come back down. Okay. Now, where might we use this? We've also probably want to work an example problem because this comes up again. Why is it called mean value? Well, This, I'd argue, this is the mean value. This is the average slope. Maybe that's a mean slope. Oh. So why is this called the mean value theorem? The mean value theorem, meaning that it, we talked about an average slope here, right? Average slope. What's another name for average? Mean. Mean slope. So there has to be an instantaneous slope equal to the mean slope, hence the mean value theorem. Okay, back to our study of the mean value theorem, and this might be an example of a homework problem you might get in this area, and you'd see here we have we're given a function. We're given a function f of x is a nice little quadratic function. We're given it on this interval from 0 to 1. They want us to find c in the interval 0 to 1 such that it satisfies the mean value theorem. Okay, well, first of all, problem doesn't require it, but I think we could we get a little bit of a picture of this thing. If I put in 0 here, I get -1. And if I put in 1, I get 2. So 0, -1. I get 2 is, what is this, x minus 1. Okay, and I'm just going to assume, I don't know, it goes through like that. Maybe some kind of quadratic thing. It's a quadratic. I'm going to draw it like that. I could think a little bit longer where the minimum hits here. But anyway, here's my function. And first of all, is it continuous? Continuous, check. Does the derivative exist? F prime exists? Check. All right. So what's my secant line? Well, let's find out. I would draw this secant line here. And so what is it? F of B, or F of B minus F of A over B minus A. That, in this case, B is equal to 1, so F of 1 is 1, 2, it's 2, right? It's 2 minus, if I put in a 0, I get -1 over what? Over 1 minus 0, so minus 0, sorry. So that's going to be equal to 3. Okay? So what the mean value theorem then says, it says there must be a c between 0 and 1 such that f prime of c is equal to 3. Well, what's f prime? Okay, what is f prime? Maybe I should change colors a bit here. Change colors. F prime of x is equal to 2x plus 2. So 2x plus 2 equals 3. Where does it equal 3? I'm going to do a little bit of algebra here. And I'm getting 2x is equal to 1. Oh, guess what? X is equal to x being equal to 1/2. Okay, so at x equal to 1/2, which almost looks like my picture here. Okay, if this f prime at 1/2 must equal 3. Okay, so what's my c value? Find c. C is, in this case, the answer would be c is equal to 1/2. At 1/2, you'll see the instantaneous slope of the curve is equal to the average slope of the curve, or the mean slope of the curve, the slope of the secant line, okay? And this is equal to f prime at 1/2. See you soon.